Okay, so we are going to start. Just discuss the first problem. I think no one would have problem with this one. So, am I audible? Can you just confirm one?
Yes, sir.
Okay. So, uh, the first question tells us that uh, we have a we have a clothing store where there are for every two shirts we get a third one for free. And now uh, we have bought X shirts. So, how many total shirts we will get? So basically, this is nothing but whatever number of shirts we buy, and that by two will be the free number of shirts. So that is total number of shirts we'll get by X plus X by two. So this is the answer basically. So anybody has any doubt with this one? This is very simple. I think everybody can get this. Anybody having any doubt, you can ask me about this question. Okay, so we can proceed to the next one. Hello, am I not audible?
Audible, sir.
Audible, sir.
Okay. So somebody wrote it in the chat, that's why. Okay, so uh, next question. Now this one says that there are two players in the game. Now Alice has A slices of cake and Bob has B slices of cake. So ultimately we have to make A equal to B. Otherwise, whoever has less number of pieces, uh, he or she will be unhappy. So until we make A equal to B, there is unhappiness. So now this person Charlie doesn't want any of his friends to be unhappy. So uh, whenever somebody is having more number of cakes, he will just eat half of eat half of the cakes of the one who is having more number of cakes. So suppose A greater than B, then he will eat half of A's cakes, and if B greater than A, then he will eat half of B's cakes, and he will continue doing so until both of them become equal. So this is also very simple because uh, we have to just check until A equal to B, and we just have to do whatever he's saying. And one thing important to note here is he says that it will be rounded up. Suppose there are if the suppose A equal to 2 and B equal to 5 here as given in the question. So Charlie will eat half of B's cakes because B is greater than A, and which will be 5 by 2, but it would be rounded up. So three slices he will eat. So B will be 2 after this. So B will be minus equal to 3. So after this operation, B equal to 2. So A equals B condition is held after this. So basically what we have to do, we just take input A and B. I'm just explaining you the code because there is nothing in the logic. So suppose A, we have to continue this while A not equal to B. So if A greater than B, then we have to eat half of A's cake. And this is the rounded up thing. A plus 1 by 2, this is actually rounded up. A by 2 rounded up. So this is actually seal of A by 2. And we have to subtract that value from A as well after eating from A because we are eating from A. Otherwise, if B is greater than A, then we'll just add B plus 1 by 2 the answer and just subtract B half of B from B. So basically updated V will be this thing B minus equal to this. So finally we have to print the answer where we have to check we have to just check the answer. What is the answer? So we just print the answer. We have added all the things until A equals B. So this while loop is taking care of the thing until A equals B. Whenever A not equal to B, we'll just loop around. So how many of you have any doubt with this problem? So you can ask me.
Sir, I did with slight change. Actually, firstly, I checked the answer and that it is odd or even, and according to that, I did. But the value of a, that is a minus equal to a plus 1 by 2. I
Yes.
directly did a is equal to a by 2 and then it run.
Yes. A equal to A by 2 is actually what? It's floor of actually floor of A by 2. So A minus equal to A plus 1 by 2 also gives the same thing actually. So
Answer. Okay.
you can just see well if A is even, then nothing has to this nothing no problem is there. So if A is odd, then only the problem is there. So if you do A equal to A by 2, so what you are actually subtracting from the previous value, that is actually A plus 1 by 2 only. Suppose A was 5 initially. A was 5 initially. If you do A equal to A by 2, that will be A updated value of A will be 2. And what I am doing is I'm just doing 5 minus 5 plus 1 by 2. So that also gives me 2. So both are fine actually. Updated value of A will be A by 2, and you can just do it by this also. So yes, formulas can vary, but the logic is the same. We have to continue till it. So anybody has any problem with the logic? Implementations can be done in various ways. So
Sir, one more doubt is there.
yes,
Uh, when I run this na by using seal and floor function na, then it didn't run. It was I think answer was 13 in the very first test case, but there is 14, I think.
try to avoid CLF4 functions, because maybe in this case it should run, because I think you have done some mistake while doing the seal and floor values, but otherwise it should run in. And try to avoid this if you can. If you know how to calculate seal of, I'll just show you how to do seal and floor using integer arithmetic. So suppose you want to calculate a by b. So a by b is giving us floor of a by b actually. This is the thing that is occurring in the,
Yes, sir.
okay. And for seal of a by b, if you want seal of a by b, you can use the formula a plus b minus 1 by b. So this gives seal of a by b. This thing a plus b minus 1. Just write it again. For the seal thing in
Okay,
integer arithmetic, you can just use a plus b minus 1 by b. So this thing you can use. And for this case, we have to do by 2. So the seal thing is a plus 1 by 2. So that is what I have used.
okay, sir, got it.
Yes. Okay. So I'll just move on to the next question. Okay. So this is the third question. Now, what is it saying? So Alice and Bob are competing in a fight bot tournament. Okay. So this play takes place on a 2D grid, and Alice starts at 0, comma 0, and Bob starts at x, comma y. So I'll just give you a diagram of this problem. This is question number 3. This is a 2D 2D. 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 2 suppose Bob is here, Alice will always start at 0, 0. So, and Bob is here. So now what is it given in the question? Okay, so the match lasts for n seconds, and every second uh, the robots can move either up, down, left, or right, and the two robots may move in different directions. So Alice has a robot and Bob has a robot. So uh, they can move in each second. They can move either up, left, or down or right. So now Alice Alice's moves are given to us with a string of length n. So whatever is the ith character in the string, that will be the movement of a robot. So if si equal to r, if the ith character is r, then Alice will move her robot 1 unit right in the ith second. So basically Alice's robots moves are given to us. So whatever Alice is doing. Now what we have to check that if if we can do some operations, if Bob can do some operations, because Alice's path is fixed. Uh, Alice, where Alice is at the ith second, we know that because moves are only given to us. So we can just figure out the coordinates of Alice's robot at any time. And what we have to do, we can have to check whether Bob can, if Bob can come up to that square, means wherever Alice, suppose I'll just show you in the diagram. Suppose at the ith second, Alice is here. So do we have any sequence of moves so that Bob can reach here after I seconds only? So after equal time, suppose after 4 seconds, after 3 seconds, Alice is here. Now we have to check after 3 seconds, can Bob reach here or not? So basically, this is the question. So wherever Alice is at after the ith second, can Bob reach there after I seconds or not? Exactly there, exactly at that point. So basically, this is the question. Anybody has any doubt with the question?
Sir, is it okay if Bob reach lesser than the time given?
Okay, so if Bob reaches less in less time than uh, it has to reach, so if he can reach, so we have to check whether he can just move up, down, or something like that, so that he can waste some time. So the question says we have to reach at exactly. How we'll solve that? I'll just show you. The solution is solution we can discuss, but the question says we have to be at the same location after the same time. So any doubt
Yes.
with the question? So we can discuss the solution after that. Okay. So I think no doubt with the question. So okay. So first of all, what we will do, we'll just discuss the approach. Uh, these are the starting coordinates of Alice because Alice is starting at 0, 0. So now I seconds, after any I seconds, we can just iterate over I. So after I seconds, let the coordinates, we know the coordinates, we can just figure it out using after traversing over the string. Suppose the string is R, L, R, R, R. So first of all, after first second, he'll go to 1, 0. Then again left. So after first second, after right move, x coordinate increases. After left move, it again goes back to 0, 0. Again after right move, he goes to 0, 1, 0. And again after right move, he will go to 2, 0. So we can just figure out the coordinate after the ith second. Suppose this is x comma xi comma yi. After ith second, the coordinates of Alice. Okay. So now Bob, we'll see whether after I seconds Bob can reach xi comma yi. Suppose Bob has initial final Bob has initial coordinates x comma y, and he has to reach up to xi comma yi after I seconds. So now Bob is starting at x comma y, and he has to go till xi comma yi after I seconds. So how we'll check that is we'll just check the shortest distance between this thing. What will be the shortest number of moves? This would be x minus xi mod plus y minus yi mod. This would be the Manhattan distance only. Anybody has any doubt up till this? What is the minimum distance to reach from x comma y to xi yi up? After I seconds, that part we'll discuss, but we have to cover minimum this distance. So anybody has any doubt with this? Okay. Okay. So this is the minimum distance that Bob has to cover. So if this is less than equal to I, then he can cover this distance in I seconds. So every second he's covering one distance. So if this is less than equal to I, then Bob can cover this distance, this much distance, this x minus xi plus y minus yi mod, this thing he can cover if this distance is less than equal to I, because Bob can cover at max distance I after I seconds. But one thing we have to note, suppose this is just I minus 1, or rather I minus some odd number. So basically, what is the meaning of this? So suppose I'll just show it again. So suppose Alice reaches here after 2 seconds. He just moves right and again right. So here is Alice, and suppose Bob was somewhere here at the starting only. So after 2 seconds, Bob has to reach here. So is it possible? Is it possible for Bob to reach here after 2 seconds from here to here? Alice was here.
In the 1 second it will reach.
In 1 second, he will reach. So this condition is definitely satisfied. But he has to move. He has to make a move in the next second as well. So he cannot be at this position after 2 seconds exactly. So this is the thing I'm telling. So after 2 seconds, exactly 2 seconds, he cannot be exactly here. He can reach
Yes.
here, and then he has to move away. But if he had something like he was somewhere, suppose he was at this index only. So in this case, xi minus x minus xi plus this thing y minus yi, this thing would have been 0 if Bob was here only at the starting and Alice comes here after 2 seconds. But now he can just move to the right and then to the left, wasting 2 moves and coming back to the same position. So if it is less than I, if it is less than equal to I, and the difference from I is a multiple of 2, then Bob can reach xi yi after I steps. So basically, I'll just I'll just tell d equal to x minus xi plus y minus yi. This is, I'll just set it equal to d. And if D equal to, what will be the condition? If D less than equal to I, so basically after I steps, he can reach here, Bob can reach here. And another condition is I minus D modulo 2 should be equal to 0. So this condition is for reaching here, reaching the xi yi position, and then wasting some moves. So you need even number of moves to waste some moves. Just move left, right again and again. And wasting some moves, he can stay at that position only. So this should be the condition. This is the condition. So anybody has any doubt with this, you can ask it.
Uh, yes, sir. Actually, I made this, but this situation I could not understand. So please, can you explain one more time?
Okay, what are you not getting? This D equal less than equal to I part or this thing?
Uh, this if a statement.
Okay, so D is the minimum distance that Bob has to cover. This is fine.
Yes, sir. This is fine.
And in I seconds, he has to cover D distance. We'll check for for every I we are checking. So we have to, for each I, we have to check whether D is less than equal to I or not. So if
Yes, sir.
D is less than equal to I, Bob can just reach there in D seconds, right?
Yes, sir.
So he will reach there, and how many seconds are left for Bob? I minus D,
Yes, sir.
and he has to waste these moves, right?
Yes,
He
sir.
has reached here in D seconds, and of the I minus D remaining seconds, he has to just waste these moves. So waste these moves, he has to just do left, right like this.
Yes, sir. Yes, sir.
But if I minus D modulo 2 has to be 0, because we need even number of moves to waste moves. Are you
Yes, sir.
getting
Got.
that?
Yes, sir. Definitely got.
So, so is this condition clear to everyone?
Yes, sir. Thank you.
Okay, so I'll just go to the code. If anybody has any doubt, you can ask. Okay, so we take the input. We have the input string, which is the move of Alice. So I just iterate over all i's. So I equal to 0 up till n, and I just initialize starting coordinates of Alice as 0, comma 0. So x coordinate was 0 and y coordinate was 0. So xs is actually the current coordinate of Alice actually. So if means the ith character is left, so I'll just decrement. If ith character is right, I'll just increment x. If ith character is up, then I'll just increment y, and otherwise in decrement y. So this xs and ys will give us the coordinates of Alice after I plus 1 second. So this is basically Alice's coordinates. So this is actually xi, yi as we have discussed. This is xi and yi after I second Alice's coordinates. This is xs and ys. And now we have to just calculate the Manhattan distance. What will be the Manhattan distance? Initial coordinate of Bob was xy. So the distance from xy up till xs and ys is this one, what we have discussed, x minus xs plus y minus ys absolute value. So now this is actually I plus 1th second, because we have started with 0 indexing. So this is actually I plus 1th second. So take care of that, because we have to do it in one based indexing. We can do it in one based indexing as well. So if distance is less than equal to I plus 1, so I plus 1th second, this is actually, so I plus 1th second, if this distance is less than equal to this, and distance modulo 2 should be equal to uh, this I plus 1 modulo 2. Basically, this is actually nothing but I minus d modulo 2 is equal to 0. We can write it as I modulo 2 equal to d modulo 2. So this is the same thing as we have discussed. So if for any I this is true, then we can just print yes and just terminate the function. And otherwise, if for every I this is false, then we have to just print no, and that will be the answer. So any doubts with this? You can ask me. Any doubts with the implementation or the explanation part, the logic part?
No, sir.
Okay. So okay, somebody is saying that he joined late. Okay. So I'll just quickly go through the logic once more. So what was Alice will initially start at 0, comma 0. After I seconds, we are given Alice's moves with the help of a string. So whatever move he's making at the ith second, we know. So after I seconds, we know position of Alice. This would be xi and yi. And now Bob is starting off at x comma y, and he has to come up till xi yi after I seconds. So they should be at the same coordinate after the same number of seconds, or after the same time. So that it was given in the question that we have to find whether Bob can reach Alice's coordinate after the same time. So we have to move this much distance. I'll just mark it as d. And d, what is the condition on d? We now Bob has to move at least. Bob has I seconds. Bob has I seconds, and he has to move d distance. So d should be less than equal to I. And one more thing, once he reaches the point of Alice, he has to waste some time. What extra time he is left with is I minus d, and this time he has to waste. So to waste time, he can just reach the point and then just move right, left, right, left. So he can just waste moves like this. But this wastage should be an even number. So basically, I minus d should be an even number. So this is the condition. So we have just implemented it. So I think everybody is clear with this. Anybody has any doubt? Okay. Now we'll discuss the uh, now we'll discuss the fourth question. Anybody has any doubt? You can just ask me.
No, sir.
Okay. Okay. Implementations can differ. So that would be fine if you implement it in some other way. Okay. So now we'll just discuss the fourth question. So we have an array of length n, and this has only integers 1, 2, and 3. So array contains only integers 1, 2, and 3. And also it is guaranteed that 1, 2, and 3 appear at least once in A. So they will always have an at least once occurrence. So that is fine. Now what we can do is just choose two indexes L and R. And for each index from L to R, if we can just cyclically increment by 1. So if AI was 1, we choose a segment L to R, and just wherever from L to R, wherever AI equal to 1, we can replace it with 2. We have to replace it with 2. If we choose a fixed LR, we have to replace it with 2. If it was 2, we have to replace it with 3. If it was 3, we have to replace it with 1. So this is a cyclical order. So Basically, we will choose a non-empty subarray. That is LR means a subarray from L to R, index L to R, and one to all of its elements. So if it is one, we'll just replace it with two. If it is two, we'll replace it with three. And if it is three, we'll turn it into one instead. So that is what is the question saying. So now what we have to answer is in how many ways we can perform this operation exactly once. So we can perform this operation exactly once. And we have to perform such that the final array still contains at least one occurrence of 1, 2, and 3. Okay. So we'll just go through an example one. So final array should contain an every element. So how many ways we can just apply the operation? So I'll just go through an example. I'll just go through the first example. This is problem number 4, according to div 4. So just take the first example. We're given the array 2, 1, 3. Okay. Now what we can do is choose L and R, and we can just increment all the values from L to R. Suppose we choose L and R as this thing, L equal to 1 and R equal to 2. So this subarray is chosen. So what we will do, we'll just replace 2 by 3, 1 by 2, and 3 will remain 3 because it's not part of the subarray. So this thing, this array, the modified array after choosing LR, this thing doesn't contain all the three values 1, 2, 3. So this is an invalid choice. So this is an invalid choice. So this LR won't work. Okay, so this LR won't work because after performing the operations on this LR, L equal to 1 and R equal to 2, we get this array. And after this array doesn't satisfy the condition that 1, 2, and 3, all of them occur in them. So we have 2, 3, 3, but do not have 1. So this LR is not valid. So what will be a valid LR for 2, 1, 3? If we choose L equal to 1 and R equal to 3, what will happen? 2 will convert into 3, 1 will convert into 2, and 3 will convert into 1. So now this modified array has 1, 2, 3, all of them. So this is a valid LR. So this is a valid LR. Okay, so we have to check how many valid LRs are there. So basically, we have to check whether how many valid LRs are there. How many LR pairs are valid? LR are valid. So after performing the operations, the array has all the three elements. How many waves you can perform this operation exactly once, so that the final array will have 1, 2, and 3 at least once. So all of them are present. So basically, how we'll proceed with the question. So the approach is very important. So basically, we will see how many cases are invalid, how many are invalid cases. So suppose, first of all, initially array has some number of ones and twos and threes. So all of them are present. That is given in the question. Now we have to disappear some value. from the array. So we have to either make one disappear from the array. So we have to disappear some value from the array. But can we, first of all, the question is, can we disappear two values? Suppose what do I mean by this is, can I disappear ones and twos completely, or any other pair which has two, 1, 3, or 3, 1? Can I have to disappear some value completely. That is that will form an invalid case. So to disappear, either I have to disappear one value completely, or we can choose two values and disappear them completely. So can I disappear 1 and 2 completely?
And
Because if I want to disappear 1, I have to choose all indexes where there is 1. So 1 will be not be there in the final array. Ones will be converted into 2. So ones will be converted into 2. So 1 and 2 cannot be disappeared simultaneously. Are you getting that? 2 will be converted into 3. If I want to disappear 1 and 2 completely from the array, ones should be completely disappeared. So I have to choose all indexes where 1 is there. So if I disappear 1 completely and 2's also completely, this I have to choose this LR so that ones are completely disappeared. So 1 will be converted into 2. This one will be converted into 2. 2's will be converted into 3. So 1 and 2 both are not simultaneously disappeared because 1 is converted into 2. Are you getting this? We cannot disappear two values simultaneously. That is my point. Whatever LR I choose, I cannot disappear two values simultaneously. That after performing the operation, we are left with only one value in the array. Suppose whatever the array was, 1, 2, 3, 1, 2, 3, we cannot choose an LR, we cannot choose LR such that after performing the operation, we have just one value left in the array. Like this. This cannot be the case.
yes, sir.
At least two distinct values are always present in the final array. This is not possible. Are you getting this? So anybody has any doubt with this? That after performing the operations, we cannot be left with an array which has a single value only. So at least two distinct values will be present.
Yes, sir.
Okay. Okay. So fine. So now what we can do is, now we have to just think about uh, disappearing single element. So we can just disappear 1, we can just disappear 2, and we can just disappear 3. Uh, we can just disappear 3. So to disappear 1 totally from the array. So I do not want 1 in the final array. So I have to take at least the first index of 1 till the last index of 1. We have to take at least this subarray, first index to last index. So is this clear? We have to take at least this subarray. I want to disappear 1 from the subarray, okay? From the array. So the final array will not contain 1. So so to disappear one, we have to take at least this range. Okay, so is this fine? The first index of one till the last index of one. Okay, so we can we have to at least take this. This is low, I'll just mark, and this is high. Okay, another case is that for the case of one, if 3 appears in between these low and high indexes, if 3 appears in between the low and high index, so this 3 will be converted into 1. So our point of disappearing 1 from the array is failed. So 3 should not appear in between low to high. This is another condition. I want to disappear 1 from the array. So I'll just choose the low index as the first occurrence of 1, high index as last occurrence of 1. And if in between that 3 comes in, so that 3 should be converted into, that 3 will be converted into 1, which makes my failure, because if 3 is converted into 1, what is the point of disappearing 1? 1 cannot be disappeared from the array, right? Is this clear? Okay, 3 should not appear, basically. This thing should not appear. Okay, suppose this was the array, so 1, 1, 2, 1. So 3 does not appear. That is fine. Now, if we just apply the operation in this sub-array from low to high, then ones will be converted into twos and 2 will be converted into 3. So final array does not contain 1. Uh, so our invalid case, what we were discussing, our invalid case will be formed. So we are just counting the invalid number of cases. We can just subtract invalid number of cases from total number of sub-arrays. So that would give me the answer. So basically, what are we doing? We'll just checking whether from the first index of 1 till the last index of 1, if we can remove that, and 1 is removed totally from the array. Okay, so for similarly for 2 and 3, you can do it. So for if we want to remove 2 completely, we have to choose the lowest index of 2 till the highest index of 2, and in between 1 should not come. 1 should not come, because if 1 comes in between, then this 1 will be converted into 2, which makes no sense because we are trying to disappear 2 from the array totally. Okay, so for the 3 case also, we have to just check the first index of 2, and 2 should not come. If 2 comes in, then invalid cases cannot be found. Okay, so now we have just got this array. I'll just show you the 3, 2, 1, 1. Now this subarray has to be chosen at minimum, this low and high. We are assuming that 3 doesn't come in between this low and high. If this doesn't come between this, so how much can we extend this low? Can this low be extended to the left, and can this high be extended to the right? Because we have to choose subarrays. This is the minimum subarray we have to choose. But we can extend this high towards the right and the low towards the left. So how much can we extend the low to the left? Low can be extended to the left until 3 is encountered. I'm telling for the case of 1. If 3 is encountered, if I take this as well, 3 comes in the subarray of 1 and our failure. So what is the point of disappearing 1 if 3 becomes 1 after this operation. So we can extend this low to the left here up till this. So are you getting this? This can be a valid low, and this up till this, but we cannot include this into the low. If we include this, if we include this as well, then 3 comes in between. So 3 is encountered. So what is the point
You
of
cannot.
disappearing 1? Because 3 will become 1 after the operation. So is this clear? If you have any doubt, you can ask.
No, sir. Yeah.
Similarly, we can extend the high towards the left until 3 towards right, sorry, until 3 is encountered. So how many subarrays are there? So how many subarrays? So low can be, suppose we can extend low till low 1. So how many subarrays are there? Low minus low 1. We can extend low till low 1 up till the left. So low minus low 1 multiplied by high 1 minus high. I'll just show you what high 1 and low 1 are. So what is the minimum thing? This is the minimum thing. So I just want to delete. This is low and this is high. This is the lowest index of 1. This is the highest index of 1. In between, there can be 2s, but not 3s. If 3s are there, then it cannot be an invalid case because we cannot disappear the value 1 from there. So this is the lowest index and the highest index. To disappear all ones, we have to choose at least this. And suppose high can extend up to here, up to this index high 1. Suppose at index high 1, 3 occurs from the first time. And in the low 1 index, 3 occurs for the first time. So low can be extended up to low, we can take here, we can take here and here. Up till low 1 plus 1 we can take. Because low, if we take low 1 as low, 3 is included in the subarray, so this is not valid. So 3 cannot be included in the subarray. So similarly for high, up to high 1 minus 1. So how many total subarrays this high can take values? What values can they take? High, from high to high plus to high 1 minus 1. So how many values are there in this range? High 1 minus high values are there. These many values our right pointer can take, the right end can take, and the low end similarly can take low minus low minus low 1 values. So this multiplication will give us the total number of subarrays. Are you getting this? Anybody has any doubt with this? How we are getting to this? How many number of subarrays we have? If there was a 3, what would be have been the high and low? So didn't get your question. Can you just ask again, or rather unmute yourself and ask? Somebody asked it out. So how many subarrays are possible? So this pointer can take values from high to high 1 minus 1. So these many values are possible for the right pointer, right end. And these many are possible for the left end. If I choose any pair from these values, if I choose anything from here and anything from the left end, we get a subarray. We get a subarray such that 1 is deleted. 1 is totally deleted, and also 3 doesn't come in between. so that one will not be formed again. So that is basically the thing. Did everyone get what we are trying to do? If you have any doubt, you can ask me. Any doubt, you can ask me. So I think everybody is clear with this. Okay, so basically we have done this for one. For one, I have discussed the entire case. Now we can do similarly for 2 and 3. So for 2, we have to make 2 disappear from the array. So at least the low thing should be at the lowest index of 2, and the high thing should be at highest index of 2. So every 2 is converted into 3. So I have to make 2 disappear. I'm trying to disappear 2 from the array. So every 2 I have to select. So lowest index of 2 up till the highest index of 2 we have to choose. Now one should not come in between. If one comes in between, this one will also be converted into 2. So new 2 will be formed. So there is no point of disappearing 2. 3 can come in between. 3 can come, but 1 should not come. This 1 is invalid. So I have to disappear 2 from the array. So 3 can come, but 1 should not come. So I'll check what is the just left index, and this low can extend up to where 1 is coming. If 1 is coming, then we cannot take this. This is the low one index where 1 is coming for the first time. And suppose there is a high one index where 1 is coming for the first time after high. So we cannot take up, we can take up to here, high 1 minus 1, but not up till high 1. High 1, after high 1, this 1 will also come in the subarray. So that 1 will be converted into 2. So there is no point of disappearing 2 from the subarray. So similarly, we'll check for 3. How many subarrays disappear 3 from the array? So we have to choose 3 as the low and high, lowest index of 3 and highest index of 3. And in between, 2 should not come because this 2 will be converted into 3. So 2 should not come. 1 can come. So 1 will be converted into 2. That is fine. We want to disappear only 3 from the subarray. And now suppose here comes 2 and here also comes 2. So up till this low can extend and up till this high can extend. So is this fine? So total number of subarrays can be calculated by number of possible taken values by low and multiplied by number of possible values taken by high. So is everyone fine with the approach, what we are doing? For 1, 2, 3, we'll check how can we just make that value disappear from the array. Low minus low 1 plus 1. Okay, so I'm just considering low 1 as the index of the unallowed value, means the um, invalid, this value is not applicable. We cannot take 1. So how many values it can take? Low minus low 1 only, not low minus low 1 plus 1. If you had taken, so what values we can be taking? We can take value low minus 1 and up till low minus, sorry, up till low 1 plus 1. These are the applicable number of values. Low minus 1 and low 1 plus 1 for the lower index. So how many values are there? These many values are there. Low, this thing, minus this thing plus 1, minus low 1 plus 1 plus 1. So this is basically low minus low 1. Low 1 is the index where the invalid value occurs for the first time. So that is the thing. Did you get? Okay. Okay. So I'll just go on to the implementation part. So basically what we are doing, we'll take the, okay. So first of all, I need the indexes where that where I value is occurring. So we can vary I from 1 to 3. So I'll just first declare that the 0th index, everyone is occurring at the 0th index. I'll just assume that. After that, whatever AI value will be there in the ith index. So V of AI, this is storing the indexes of the value AI. So if AI is 1, one's positions will be stored in the V of 1 vector. In the V of 2 vector, positions of 2 will be stored similarly for 3. And I'll just initialize the answer as the total number of subarrays, and we'll just subtract how many of them make one value disappear. So I have to disappear one value from the subarray, and I'll just subtract those many subarrays from the total number of subarrays. So that would be a better approach. So I'll start with answer as initialized as the total number of subarrays. Now what are we doing? Now we are iterating from 1 to 3. So I want to make value I disappear from the array totally. So we have to take its first occurrence, which will be vi comma 1, ith values first index, first occurrence. That will be vi comma 1, I1, vi1, this thing. This is the low. And the high will be vi comma vi dot size minus 2. So what we are doing, I have assumed that first occurrence is always 0, 0th index. I'll show why is it important and why it will help. So this I am assuming the first occurrence. So actual first occurrence is at the first index, not at the 0th index. So we are storing 0th index as for every value I, we are storing as 0. So the first occurrence will be vi comma 1. This will be the first occurrence of I. And high similarly will be vi comma vi dot size minus 2. So we have considered last occurrence to be n plus 1. So actual last occurrence in the array would be vi dot size minus 2. So this is the high and the low. Okay, so this commission. Okay. Okay. So now this thing is the low and high. We get the lowest index of I and the highest index of I. We are getting till here. Any doubt? You can ask me if anybody has any doubt till here. Okay. Now what we are doing, we have to do this operation till from low till high. I'll just see what are the values. So for that, from low till highest index, I'll just create a set called count, and I'll just insert aj from low till high into that. So for suppose I'm doing it for 1. So for 1, we are getting, suppose I equal to 1. For 1, we are getting the lowest index of 1 and the highest index of 1. And from lower till high, all the values I insert into the count array, and I check whether 3 occurs. This value, this x1 is actually, this x1 value will map 1 for I equal to 1. This will be equal to 3. What this x1 value is doing, I'll just show you. Okay, cannot add comments here. So this value just, what is x1? I'll just show you. You can just figure it out yourself or create a map. For 1, we do not need 3 in between. For 2, we do not need 1 in between. For 3, we do not need 2 in between. So basically, x1 value is just mapping 1 to 3. For I equal to 1, this x1 value will be 3. For I equal to 2, this x1 value will be, what do we not need in between? 2. Because if 1 is between 2, so that 1 will be converted into 2 and so on. So this maps 1 to 3 and 2 to 1 and 3 to 2. You can check yourself this value. And if we find from the low till high, if I find x1, so if count dot find x1 value was found, this is not equal to c count dot n means x1 value was found. If it was found anywhere in between, then we cannot do anything. Then we cannot disappear this value I. So how many subarrays disappear I? That would be 0. So we do not add anything into the answer. So this is, I'll just continue. Otherwise, if there was no 3 in between the low till high index, there was no 3. For the case of 1 I'm discussing, you can just do it for similarly for 2 and 3. So if no 3 was found in between this, so we can just check how much high can extend till high 1. Suppose it can extend till high 1. So what we'll do, we'll go into the positions of 3 where the positions of 3 are occurring. This would be v of x. V of x1 is basically giving us the indexes where 3 is occurring. So I'll just go into that vector and search for a value greater than high. So high can extend up till high 1 because high 1 is the first index greater than equal to high where 3 is occurring, because I'm going into the vector of 3. This x1 value maps 1 to 3. So now similarly low 1, how much low can extend to the left? High can extend to the right till high 1 and low can extend to the left till low 1. So how we are getting this? We go into the index vector of x1 and just search the just lower value than low. So how much we have to subtract? These many subarrays will create a problem. So I initialize the answer as total number of subarrays and I'll just subtract high minus high into low minus low one. And finally, whatever the answer is left, this will be the answer. So how many of you have any doubt with this? Any doubts? Any doubts? You can just unmute yourself and ask. Any doubt with the implementation or with the logic? Okay, so I hope it's clear. Okay.
Hello, sir. Am I audible?
Yes, yes, you're audible.
Can we implement this without using set? Like we will just use linear search for finding low
Yes,
one
yes,
and high.
sure. Because linear search and set would be the same thing, whereas set would consume a little more time. So you can just do linear search because we are just brute forcing, right? From low till high.
Yes, sir.
So you can just linear search whether x1 is present in between the high to lower. So x1 thing also you can just create a map and store. I had just used this formula. So this is nothing but it just maps the values. For I equal to 1, this will take value 3 and so on. So if x1 is occurring in between the low and high, then no answer is possible. No subarray will disappear the value I. Otherwise, we can just calculate low one and high one up till how much high can extend, how much low can extend to the left, and just calculate how many subarrays are there so that this thing will disappear. So I think this is clear. Okay, so just discuss the next question. If anybody has any doubt, you can ask me right now. with the previous one. Okay. Now the next question. What we are given is, okay, so I have solved it only partially. So this, fifth question, I have done it only partially. So I'll just discuss the partial solution only. What was here is k less than equal to n was there. So hmm, first of all, I'll just show you the question. What is it telling? So we are given an array of n integers, and we have to perform an operation exactly k times. What is the operation? We have to choose one index and multiply the value at that index by 2. So if it was AI, we will just replace AI with 2 into AI. So find the minimum possible sum of the array after all k operations have been performed. So we have to find the minimum possible sum after all the k operations has been performed. So since the sum can be very large after performing the k operation, so we have to print it modulo 1 in 9 plus 7. So very simple statement. We have to perform an operation. We have to choose an index. Suppose this was a1, a2 array is given. We have to choose an element and just set it as AI equal to AI multiplied by 2. This is the operation. So we have to minimize the sum at at the final step after k operation. So what we can do, what we have to do, we have to choose a minimum value from this array. Whatever was the minimum value. So whatever was minimum, I'll just represent it as a minimum, and I'll just set it at a minimum into 2. Because performing one step and not incrementing the sum by a very large value, we have to just choose the minimum of the array and just multiply it by 2. So is this clear what we are doing? We always pick up the minimum array. We have to minimum element of the array, not anything else, not anything larger or something. So why we are picking the minimum? Because we have to make the increment in sum as minimum as possible. So we have to just, okay. So I have to take the minimum value of the array and just multiply it by 2. So is this clear what we are doing? If anybody has any doubt, you can ask. Okay. So now this storage is very difficult. This, if we store the array like this, a1, a2, and till an, these values will soon reach very high values. So these will soon overflow because we are multiplying by 2 at each step. So if something is getting multiplied by a very large value, this storage might become difficult. So we can just store logarithms base 2, log 2 AI. So since log is an increasing function, so for AI for which AI is minimum, log 2 AI will be also be minimum. So log 2 values can be stored. And what is happening to the log 2 values after we multiply it by 2? Log 2 values are incrementing by 1 only. Suppose I am storing these values. I just modify the array like this. A2, log 2, A3, and so on. I'm just storing the values base log 2. So now whenever I perform the operation on any one of them, the log2 values of it increments by 1 only, because log of 2 into some x is log 1 plus log x. So after multiply by 2, this log value is just getting added by 1. So is this clear? We are storing the log values, and whoever's log is minimum, we are just incrementing that, and the log value of it will just increment by 1. So we do not have to multiply totally, we can just increment the log values. So whoever's log value is minimum, I'll just pick that up. Increments is log value by 2, increments is log value by 1, which is equivalent to multiplying it by 2, and just we'll just add accordingly to the answer. So are you getting the approach what we are doing? Whoever's log value is minimum, we'll just pick up that and just multiply it by 2, which is equivalent to incrementing the log value by 1. To get the original value back, do we need? No, I'll just show you the implementation. So the logic is basically this, what I have used. So whoever's log value was minimum, I'll just increment this log value by 1 and add accordingly to the answer. So I'll just show you the implementation. Everybody is clear with the approach, right? Anybody has any doubt in the approach? Okay, somebody is sharing code. I'll just show you my code and you can write it in your way as well. Okay, so what we are doing? First of all, take the array's input and we create a set of pairs which will store double values, comma integer values. So why this is needed, I'll just discuss. And in this set, we just insert log2 of AI. So basically log base 2 of AI, comma AI. So whatever the value was, we'll just insert it as well. So now we have to perform k operations. Since I have solved only the k less than equal to n part, so we can iterate over n over k. So while k minus minus, I'm taking the first element of the set. What will be the first element of the set? Whoever's log value is the minimum. And we are just, that would be a pair. Okay, so this element equal to star IT, this would be a pair. And we are taking the first element and deleting it from the set. Okay, we'll just increment the log value and then modify it, and we'll just reinsert it into the set again. But before that, I'll just delete it because before inserting it, otherwise multiple copies will be there. So whenever I pick up the first element, I delete it from the set, and element dot first, what it was storing, the log value. The log value is incremented by 1, and the value at that position is just multiplied by 2, right? So just le dot second, that was storing the value at that position, that is multiplied by 2, and I'll just take the mod. So again insert it back to the set, le dot first, and we'll just do it again and again till k exhausts. So k operations are performed. We'll initialize an answer as 0, and whatever the second values or whatever the modified values of the A's were there, that would be added, and just print the answer like this. After performing the steps, the log values are incremented by 1 and the value at that index just gets multiplied by 2, and we can just take modulo because we have to sum it up at the end. So is this clear? Everybody is clear with the implementation? Anybody has any doubt? Whoever's log value is minimum, I'm just taking that up. Okay.
Sir, why are we like taking log value?
Okay, so log values, the multiplication by 2 factor. Okay, so the multiplication by 2 factor which we were doing, that becomes a much easier, right? Whoever's log is minimum, that value also has to be minimum, right?
Yes, sir.
So we pick up the minimum value because the first element of the set will be giving us the one whose log value is minimum, right?
Yes, sir.
And then we just do LE dot second, means whatever the value it was containing, that would be multiplied by 2. And since we are doing the mod at this step, so if we just stored AIs, then it would not have worked, because somewhere if it has become greater than mod, and after taking the mod, it takes up a very small value. So that is not the actual value it was storing. So I had used the log values so that we have a comparison ready, that whose value, who is the minimum value in the array currently. So whoever is the minimum value, I'll just multiply it by 2, and that value is stored in the LE dot second, the second portion. Are you getting this? So if you have any doubt, you can ask it again, or are you clear with this? Okay, so final answer can be just calculated by taking the whatever the elements become after the operations, k operations, that would be LE dot second, and just take mod at each second in the answer. The final answer can be calculated easily. So for the hard version of this, mm, hard version of this, I couldn't solve it in the contest. I thought of some binary search approach. So I can show you some code that might work after some modification. I have not completely solved it yet. So that would not be much useful. So I've not solved it since. So we can go on to the next problem, the beautiful flip, and that would be the last problem we will be discussing. So if anybody has any doubt with this problem, you can ask me. So okay, so this would be the last problem we'll be discussing. So what is given in the question? This is the sixth question. Okay. We have to define the beauty of a binary string to be the minimum number of zeros and ones as present in it. So just show you what is a beauty. So here are 5 zeros and 3 ones. So minimum of these two, that is 3, will be the beauty. So whoever's count is minimum, we have to take that. Okay. So we are given a binary string of length n along with an integer k. Okay. So we are given a binary string on which we have to perform operations, and we are also given a k. So what we can do, we can choose a substring of s of length at most k and flip all the characters in it. So we can just choose a sub array or substring, whatever. We can just choose this and flip all the characters in it. So 0 will be converted into 1, 1s will be converted into 0. So this thing will become like this. And after performing the operation, what is the beauty? We have to check. So what will be the beauty? So there are 6 ones, and 2 zeros. So beauty will be minimum of 6 comma 2. That would be 2. So we have to choose basically we have to choose a subarray and its length can at most be k, and we can flip all the characters in it, and we have to flip all the characters in it. And after that, we have to maximize the beauty of S after this operation. So what is the meaning of maximizing the beauty of S? So suppose there are count 0 number of zeros, count 1 number of ones. So what we have to do, we have to maximize the beauty. So we have to maximize this value, minimum of count 0, count 1. Right. So what we have to do is bring count 0 and count 1 as close as possible. That would only maximize the beauty. Because count 0 plus count 1 is fixed, equal to n. This is fixed. And we have to maximize the minimum element. So we have to bring both of them close to each other. So we have to do count 1 and count 2 as close as possible. Everyone is clear up till this, what we have to do to maximize the beauty. If anybody has any doubt, you can ask me. Okay, so basically what we are doing, what is the flip operation? Now we'll discuss about the flip operations. Suppose this is a string 1 0 1. Suppose a character is 1. After flipping, what is the effect on count 0 and count 1? If we flip a 1, 1 is converted into 0. So count 1 is decremented by 1 and count 0 is incremented by 1. So I'll just define a difference thing. Which we have to minimize. I'll just define difference equal to count 0 minus count 1. Okay, so we have to minimize this difference thing, or rather the absolute value of this difference should be minimized. Difference should be minimized. Now, whenever 1 is converted into a 0, count 1 reduces by 1 and count 0 increments by 1. So what happens to the difference? So difference is actually, since count 1 is getting equal to, what will happen? Count 0 plus 1. Count 0 is converted into count 0 plus 1, and count 1 is converted into count 1 minus 1. So basically it was previous difference previous difference plus 2. So whenever one is converted into a 0, so difference is incremented by 2. And whenever a 0 is converted into 1, similarly, this difference decrements by 2. Is this clear? This difference thing, is this clear? We have to minimize the difference. Okay. So since we have to minimize this difference, either if I convert a 1 into a 0, this difference increments by 2, otherwise it decrements by 2. And we have to make the absolute value of this difference as small as possible. Because if difference is minimized, then our answer can be easily found. Because ones and zeros should have, the count of ones and the count of zeros should have minimum difference. So they should be as close as possible. And the minimum of them will be higher. So I'll just show you an expression as well. So suppose count finally, if we can just do like this, count 0 and count 1, this should be always equal to n. This is the first equation. And suppose count 1 is greater at the end, and we can achieve a maximum value of this d. Then what will be the minimum of the two? This would be n minus d by 2. One of them would be n minus d plus n plus d by 2, and one of them would be n minus d by 2. So I'm trying to minimize d. This is the difference thing. I'm trying to minimize this d so that n minus d by 2 is as large as possible. This is basically the answer thing. This would be the answer, n minus d by 2. Because count 1 plus count 2 has a sum n that is fixed. But the difference, we have to minimize it so that the smaller value is as large as possible. The smaller value is n minus d by 2. And for that to be as large as possible, we have to bring d as close possible to 0. So we have to minimize d. I'm assuming d is positive. So is this fine? What we are trying to do? Okay, so we are also given a k. Suppose there is a 1. If I perform a flip at this position, what change it will bring to the difference? It will bring a plus 2 change. It will bring a minus 2 change. So now we can choose any subarray up till, suppose I'm, okay, so these are the changes to the difference thing. These are the changes to the difference thing. One that would bring a plus 2 change if I take it. And we are also given a k length subarray. Now I'll just try to explain it a little more. Suppose at the ith index, I am at the ith index. Okay. And up till I minus k index, I have the values. Okay, so I'll just discuss one more thing before this. Suppose this is the ith index, and the prefix sum up till I is pref I, and the prefix sum up till this is pref I minus k. This is pref I minus 1. So this is pref I minus 2. I minus, this is pref I minus 1. Pref I minus 2. So when we do pref I, I'll just pref I minus something like pref x. So what this gives me, what will this give me, will be the sub-array sum from x plus 1 up till I. This is basically what pref I minus pref. This is the prefix sums. So this is up till ith index I am adding up. Pref I is up till ith index. Pref x is up till xth index. So this minus thing will give me from the x plus 1th index till the ith index. This is the sum. This will be the sum. Okay. So what is the importance of this in this problem? Whenever we are at ith index, suppose my r is fixed at this, r equal to I. I'm trying out to find the optimal L that would give me. I'll iterate over r. I'm assuming that r equal to I. What will be my optimal L? I just try to find L optimal so that it minimizes the difference. So one important thing is L cannot be, L minus R should be greater than, or rather L minus R minus L plus 1, the subarray length should be less than equal to K. R minus L plus 1 should be less than equal to. So when I am at R, I can decrement, I can just, this pref I will give me the sum up to R. Sum up to R. And I can decrement any pref L. I can take X. Suppose I am doing X. I am decrementing pref X. So pref X can be anything from I till I minus K. I can decrement pref I minus 1 till I minus K. Up till this, I can decrement. Pref I is the sum up to R minus. These things are valid. I can decrement any of these. So pref I minus 1, pref I minus pref I minus 1. This will give a subarray of length 1. Pref I minus pref I minus 2 will give a subarray of length 2. Pref I minus K will give a subarray of length K. But if I go beyond this, then the size will be greater than equal to K, greater than K. So that is not valid. So are you getting this, what we are trying to do? This for the pref I can just subtract anything from pref I minus 1, or I can subtract pref I minus 2, or I can just up till pref I minus K. Beyond that, it will not work. So up till this, if I do anything, I subtract any value from these values, so the subarray length is still less than equal to K. So what value is optimal? Among these values, what value is optimal? Are you getting what I'm trying to do? What value is optimal? So currently I have a difference, initial difference is suppose, and if I take up till this, I have to subtract a value. I have to find a pref I minus k such that this I minus, I have to find an index I x from I minus k to I minus 1. This index can vary from I minus 1 till I minus k. Now, if I choose the xth index, hello, am I audible?
Yes, sir.
Yes, sir.
Okay. So if I subtract, if I choose an index, so what I'll choose an index x from I minus 1 till I minus k I can choose. And how will I choose that index? That index, the summation of from x plus 1 to I, this summation, sum from x plus 1 to I, yes. So the summation should be as near to difference as possible. As we have to choose this x such that the summation from here till I should be as close as possible from difference. This is the initial difference. This is basically count 0 minus count 1. This difference has to be minimized, right? So when we are at index I suppose R equals I. Now I'll try to find the optimal L for that. This is basically my approach. And it can go up till I minus k, not beyond that. So what we'll do, I'll just maintain a set of the values from I minus 1 till I minus k, set of the prefix values, so the prefix sum values. This would be a window of length k. And it will be a set of window of length k. And of these values, I can just decrement anything from pref I, because pref I is a total summation up to ith index, minus I can choose any x from these window pref x, and the summation of this. What is the summation of this representing? Basically, this is representing the change in the difference that will occur if I choose the entire from this x plus 1 till I. This change should be as close as possible to difference. Just a minute. This change, this is representing the change just a minute. I was having a problem with this. Okay. Okay. So I can choose any index from this window, or rather any prefix sum from this window, and subtracting that prefix sum from prefix I will just give me the change that will occur. This is an array of +2, -2, +2, according to what we had done previously. Because what would be the change if we flip that particular index, we can get, depending on whether it was 1 or -1. Now we want to make the change so that the change should be as close as to of difference actually. Minus of difference, it should be as close as to minus of difference, because if we add this change, the difference is minimized. So are you getting what we are trying to do? You can ask me if you have any problem. So I'll just maintain a set of the prefix sums up till I minus k. And whenever I decrement a prefix sum from the prefix I, what I get? I get a window. I can take any value from I minus 1 till I minus k. And if I reduce this prefix sum from prefix I, it will be a window from x plus 1 to I. So I want that thing, x plus 1 to I. Basically, I need a prefix as that, so that it's as close as possible to minus of difference. Because when we subtract this value from minus of difference, minus of minus, or rather add this difference plus minus of difference, it will be as near to possible to 0. As near to 0. Because after adding that difference, we'll try to reach 0. So are you clear what we are trying to do with the approach? I'll just repeat it once again. Initially, there is some string. It has some number of zeros and ones. Suppose there are count 0 number of zeros and count 1 number of ones. Can I confirm that am I audible or not once more? Hello?
Audible, sir.
Okay. So initially, suppose this is my configuration. I'll just define a thing named difference, which I have to minimize. Why I have just discussed before. Because if number of ones and number of ones and number of zeros are as close as possible, this thing, we have to make number of ones and number of zeros as close as possible so as to maximize the final answer. So this thing we have to minimize. So what is the impact on the difference if we flip a bit? If it was a 1, it changes to 0. So count 1 is increased by 1, and count 1 is reduced by 1, and count 0 is increased by 1. So the change to the difference is a +2 change. And suppose if 0 is converted into 1, 0 to 1, if we flip like this, then it will be a -2 change. First of all, I build this array. This will consist of +2, +2, -2, -2, -2, +2, -2, -2. These are the changes to the difference that will occur. Now I fix my R somewhere here at I. I'll iterate over all I. So I fix this R. Now what we are trying to do, I'm trying to choose an L so that what was the difference? Initial difference was, this was count 0 was 5 and 3. So initial difference was basically 2 only. Now if I have fixed this right pointer at I have to choose such that the prefix sum should be -2. I'll just move back, move back, move back. the subarray sum between this L to R should be -2, so that my difference is minimized, or rather as close as possible to minus of difference. If I cannot choose mine, if this difference would have been 3, then also I would have chosen -2, because I cannot make -3. -3 is not possible. So -2 was the best we can do. So are you getting my point? So I'll just take this index and flip it. What will be the final array? This was a 1, this was a 1, this was a 0, this was a 0, and this index we just flipping. This becomes 1. This was a 1 before only, and -1 minus. Sorry, -2 means 0. -2 means was previously 0. So now what you are saying, that difference is becoming 0. Because we have chosen a subarray with sum equal to -2, this difference, the change to the difference would be -2, and this difference becomes 0. And our answer is maximized. So that thing is maximized. So what we are asking now. So are you getting what we are trying to do? We'll maintain a window of length k, and I'll just try to subtract a value, like if I have prefix I, I'll try to find out of the k length window, storing the prefix values of prefix I minus k, prefix I minus k plus 1, so on, like prefix I minus 1. I'll choose the value which is as close to prefix I plus difference. So prefix I plus difference, if I get the value as close as that, then if I subtract that prefix value, then the subarray value, I'll just search for this value in the k-length window. And if I subtract that value, then we are left with only difference, and difference change is brought. I'll just search for prefix I minus difference, in fact, because prefix I minus difference and prefix I minus difference shall bring the difference as close as possible to minus difference, and upon adding that minus difference to difference, we will go as close as to 0. So finally we have to minimize the difference. So that is what we are doing. Are you getting what we are trying to do? If you have any doubt, you can ask me. Difference of prefix sums actually gives us the subarray sum, and we'll choose such a prefix sum which is as close as possible to prefix I minus difference. Because if I choose this index, then the subarray sum will be as close as possible to minus difference, and if it is as close as possible to minus difference, then upon adding this subarray sum, means this change actually, then we can get as close as possible to 0. So is this approach clear? Is it clear? Okay. Okay. Now I'll just discuss the implementation part, what I have done. Okay, so first of all, N and K are input. I input the string. I make it 0 from 0 index to 1 based indexing, so that I have no problem with the indexes. So initial count, I'll just count the number of zeros and ones. I've just done nothing but count the number of zeros and count the number of ones here, up till here. Now, what I am doing is just calculating the difference. What is the difference value? This is count 0 minus count 1. This is the initial difference. And what will be the minimum possible value of the difference? Actually, mod of difference we have to take. Whatever the minimum possible mod of difference is possible, that would be the best case scenario. So we have to just minimize this value. And I'll just initialize d min as absolute value of the difference, the initial difference. Okay. So if it was a 0, so 0 flip to a 1, 0 flip to a 1 will make a change of +2, or rather -2. I think 0 flip to a 1. Okay, 0 flip to a 1. Okay, we can just modify it a bit according to my solution. I'll just do it once more. I had explained a bit different. Okay, so I'll explain the code once more. So initial difference was count 0 minus count 1. So whenever we encounter 0, and if I flip it, what will be the change to the difference? It will incur a -2 change to the difference, because 0 is converted into 1. So count 0 is minus minus. So this thing becomes a -1, and count 1 increases by 1. So the difference to the change made to the difference value would be -2. Otherwise, if a 1 is flipped to a minus, 1 is flipped to a 0, the difference made to the value of difference would be +2 change. Okay. So now what we are doing, if I is greater than k plus 1, so this we have just reached k more than k size. So I just erase the prefix sum up of I minus k minus 1, because we have to maintain a window of length k. So first of all, we have to maintain a window of length k. From I, we can maintain a window of length k like I minus 1, I minus 2. This thing will be maintained, I minus k. These k values should be maintained. And I minus k minus 1 should be deleted if I is greater than equal to k plus 1. So these k values are maintained in the set st. The st set initially contains a 0, because if we take 0 index, so that would have to be considered as 0. And this is basically the set which maintains the prefix sum values up till I minus k, from I minus 1 to I minus k. Now I take the lower bound from prefix I plus difference, because I have to find a subarray sum so that it's as near to difference, because that is the change that would be to minus difference, actually to minus difference. So if I search for prefix I plus difference, and if I subtract prefix I plus difference from prefix I, that would be giving me minus of difference. So I just find that value what will be that value? That prefix I minus star of IT. This is as near possible to minus difference. This thing. This will be the optimal L such that we can find the value as near to minus difference. Also, we can just with IT minus minus, we can just find the just large value than minus. This is just giving me the just large value from minus difference, and this IT minus minus will be giving me the just smaller value than minus difference. Of these two values, we are just taking the minimum, and whatever minimizes the final difference, that would be dmin. So dmin equal to minimum of this. And at the end, I'll just insert prefix I also for the next iteration, because prefix I value will be inserted. And at the next iteration, that I minus k minus 1 value would be deleted. So we have a window of length k. In this window, I'll try to find a subarray such that minus difference is the sum of that subarray, because we want to make the change as close as possible to minus of difference. So basically, this is the minimum final value, this is dmin. And now what will be the answer? N minus dmin by 2, as we had discussed in this part. I'll just show you. This n minus d by 2 is the answer, because n count 1 plus count 2 is count 0 is always equal to n, and these are the two values of count 0 and count 1. Of these two, minimum is this, and we have to maximize this, so we have to make d as small as possible. So this dmin is the smallest d. Now n minus dmin by 2 is the answer. So are you clear with the coding as well? Fine. So that's it. I had solved up till this only in the contest. So that's it for today. Stop the recording now.